Welcome to the soothing cosmos, where the wonders of the universe unfold in calm and captivating detail. Here, we journey beyond our world, exploring the mysteries of space, the beauty of distant planets, and the secrets written in the stars. If you enjoy traveling through the cosmos with us, remember to subscribe and join our voyage across the universe. All the supernovae we know of. Supernovae are among the most spectacular events in the universe. These cosmic explosions represent the violent death of a star, and in the process, they reshape galaxies, seed the cosmos with heavy elements, and provide astronomers with clues about the very fabric of reality. To study supernovae is to look into both the past and the future of the universe. Past, because light from ancient explosions has been traveling for centuries or millennia before reaching us, and future, because such explosions will one day reshape our own galaxy. Today, we will take a journey through all the supernovae we know of, from the first recorded by human eyes, to those captured by modern telescopes, and even those we await in the skies of tomorrow. The first records, ancient astronomers and the guest stars. Long before telescopes, ancient skywatchers recorded sudden new stars that appeared without warning and then slowly faded away. These guest stars were the first supernovae ever documented. The earliest recorded example comes from the year 185 AD, noted by Chinese astronomers. They described a brilliant light that appeared in the southern constellation Centaurus and lingered for 8 months before vanishing. Modern astronomers believe this was a Type Ia supernova, the thermonuclear explosion of a white dwarf star. The remnant of this explosion is today known as RCW86, a vast bubble of gas still glowing in X-rays. Nearly 1,000 years later, the year 1006 brought the brightest stellar event in human history, SN 1006. Chinese, Japanese, Middle Eastern, and European observers all described a star so bright it cast shadows at night and was visible even in daylight. Located about 7,200 light-years away, it shone at an estimated magnitude of -7.5, 4 times brighter than Venus. Its remnant, a vast shell of expanding gas, is still visible with modern telescopes. In 1054, another extraordinary event lit up the skies. Chinese and Japanese records describe a star that appeared in the constellation Taurus and remained visible for almost 2 years. Today we know this explosion created the Crab Nebula, one of the most famous objects in astronomy. At its heart lies a pulsar, a rapidly spinning neutron star emitting beams of radiation like a cosmic lighthouse. This was the first time humanity witnessed not only the death of a star but also the birth of one of the strangest objects in the universe. The Middle Ages, the sky is not eternal. The next major recorded event occurred in 1181. Chinese and Japanese astronomers again noted a guest star, this time lasting about 6 months. For centuries, its remnant remained a mystery, but in 2013 astronomers identified a likely candidate, a nebula called PA30, surrounding an unusually hot and fast-spinning star. This discovery suggests SN 1181 may have been caused by the rare merger of 2 white dwarfs. The late Renaissance brought 2 supernovae that changed not just astronomy, but humanity's entire understanding of the heavens. In 1572, Tycho Brahe, the Danish astronomer, carefully studied a new star that appeared in the constellation Cassiopeia. His observations, precise and methodical, proved that the new star lay far beyond the moon, challenging the Aristotelian belief in an unchanging heaven. The remnant of this event, Tycho's supernova, still glows in X-rays, its shockwave expanding into space. Only 3 decades later, in 1604, another supernova appeared, this time in the constellation Ophiuchus. Johannes Kepler observed it extensively, and it became known as Kepler's supernova. This was the last supernova observed with the naked eye in our Milky Way galaxy. Its remnant is still visible, a glowing shell of hot gas. Since then, no supernova has been seen in our galaxy with the unaided eye, though the universe beyond has offered us many more. Hidden explosions and the modern age. After Kepler, no naked-eye supernovae appeared in the Milky Way. But evidence of more recent explosions came to light in the 20th century. Cassiopeia A, for example, is the remnant of a supernova that likely exploded around the late 1600s. For reasons unknown, it went unrecorded by astronomers of the time, though modern studies suggest it may have been obscured by interstellar dust. Today, Cassiopeia A is one of the brightest sources of radio waves and X-rays in the sky. At its heart lies a dense neutron star, evidence of the collapsed core left behind. Supernova 1987A, a cosmic laboratory. For centuries, no supernova had been close enough to study in detail. That changed in 1987, when astronomers witnessed an explosion in the Large Magellanic Cloud, a small galaxy orbiting the Milky Way. Named Supernova 1987A, it became one of the most studied events in astronomy. Visible to the naked eye from the southern hemisphere, SN 1987A gave astronomers a front-row seat to a cosmic cataclysm. For the first time, neutrinos, ghostly particles emitted during core collapse, were detected from a supernova, confirming long-standing theories about how massive stars die. Over the decades, astronomers have watched the remnant evolve, as shock waves plow through surrounding gas, lighting up in spectacular rings of glowing material. SN 1987A remains a cosmic laboratory, allowing us to watch a supernova remnant form almost in real time. Other recent supernovae. Since 1987, no supernova has appeared so close, but telescopes have captured many in distant galaxies. In 1993, SN 1993J appeared in the nearby galaxy M81. It was one of the best-studied Type II supernovae, shedding light on how stars shed their outer layers before exploding. In 2014, SN 2014J appeared in the galaxy M82, just 12 million light-years away. It was a Type Ia supernova, the explosion of a white dwarf, and its relative closeness made it ideal for testing models of such explosions. Modern sky surveys, such as Pan-STARRS in Hawaii and the Palomar Transient Factory in California, now detect dozens of new supernovae every year. These discoveries extend far beyond the Milky Way, capturing explosions in galaxies hundreds of millions of light-years away. Though faint and distant, they are crucial for cosmology, helping astronomers measure the expansion of the universe and even leading to the discovery of dark energy. Whether or not Loeb is correct about Oumuamua, his insistence on considering the possibility has shifted the conversation. It has encouraged a new generation of researchers to think more broadly about interstellar visitors and the potential for technological signatures in astronomy. The controversy around Avi Loeb and Oumuamua is not just about one object. It is about how science responds to the unknown. Was Oumuamua an alien artifact? Probably not, but we cannot say with certainty. Was Avi Loeb reckless in suggesting it? Some say yes. Others argue he was simply being courageous, willing to follow the evidence to a possibility most scientists would not dare speak aloud. In the end, Oumuamua has left us with mystery. Avi Loeb has left us with debate. The next supernova. Astronomers wait eagerly for the next nearby supernova. Betelgeuse, the red supergiant in Orion, is the most famous candidate. In 2019, its sudden dimming led to speculation that it might soon explode. In reality, it was shedding a cloud of dust. While Betelgeuse will eventually go supernova, it could be tomorrow, or it could be 100,000 years from now. Whenever it happens, it will be one of the greatest spectacles in human history, shining as bright as the full moon. Importantly, at over 500 light-years away, it will pose no threat to Earth, only awe and wonder. Conclusion. From ancient gas stars noted on parchment to modern detections across the electromagnetic spectrum, supernovae have shaped not just the cosmos, but human understanding of it. Each explosion tells a story of a star's life and death, of matter destroyed and reborn, of galaxies enriched with the elements of life. We have recorded only a handful of supernovae in our own galaxy, but telescopes now show us hundreds across the universe every year. And while we wait for the next nearby event, we can look to the night sky and remember that every atom of iron in our blood, every bit of calcium in our bones, every element heavier than hydrogen, was forged in the heart of a star, and scattered across the cosmos by the fury of a supernova. In the end, to study supernovae is to study ourselves, because we are the children of dying stars.